we are going to discuss about the nitrous acid is produced when nitrogen dioxide dissolves in water to produce acid rain. What is the correct Lewis diagram for nitrous acid? So in order to find out that this is basically HNO2, and first we need to find out the valence electron present in them. So we have hydrogen which has one valence electron, and we have nitrogen which is going to have valence electron 5. And if we discuss about oxygen, then it is going to have valence electron of 6. So total it would become 6 plus 12, and that is going to have 18 valence electron. So if we are going to see the structures now, then let's first discuss the D option. D. Let's discuss about the number of valence electron there. So it is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21, 22. So D is incorrect because it is showing 22 valence electron where it should be 18. So because of 22 valence electron, we are going to see that it is going to be the incorrect option. So D is not the option. Then if we see option C, then we are going to see that oxygen here, if we see oxygen here, it has valence electron 2, 3, 4, 5, 6. So oxygen is going to have an incomplete octet. Because of incomplete octet, what happens? We are going to say it is not the correct structure. And if we are going to see option B, then we are going to see that here oxygen is going to have an expanded octet. Expanded octet, that means it is having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is not possible. Okay, because oxygen has here more than 8 electrons. Oxygen has more than 8 electrons, which is not possible in Lewis diagram. Then when we see option A, then it is going to be the right answer, as it follows everything. Like it is going to have 18 valence electron. How? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it has 18 valence electron. And if you are going to see that every like hydrogen has 2 electrons completed, here oxygen has 8 valence electrons done, here nitrogen is also having 8 electron in its outermost shell, and oxygen is also having 8 electron in its outermost shell. So it is the right option. In this question they say which of the species shown below does not have resonance structure. So first of all, for a molecule to have resonance structure, then it must need to have it must be one or more double bond present. There should be one or more double bond present. First is this condition, bond present, and then next condition says that there must be more than one possible position for double bond. More than one possible position for double bond. Like for example, if you see benzene structure is like this, and you can see it has double bond here, so this can rotate, so it has another position for the movement of electrons, so its resonance structure is possible. So this is not the answer. If we see carbonate, carbon is having double bond here, one oxygen, having -2 charge. So this can rotate here, then that can rotate further. And if you see ozone, then ozone is having double bond here, one single bond here, having electrons like this. So this can rotate even at this point as well. So this can't be option, this can't be option, only this is a option. Why? Because this is carbon carbon double bond, this is hydrogen, this is hydrogen, this is hydrogen, this is hydrogen, and there is. So if we see ethene, the ethene option is basically doesn't have the resonance structure. Because why? Because here the double bond can be located only in one position. It can't be rotated. It stays only in one position, so it can't be moved. So our option is going to be option C. In the next question, they say which of the following does not obey the octet rule. So first of all, it is basically going to be ClF3. And why it is ClF3? If you are going to first find the number of valence electron in them, so that is 7, because it belongs from group 7 plus 3 into 7, and that would become 28. And if I'm going to draw the structure, so first we have the fluorine here, and fluorine here, having lone pairs like this, or bond pairs. These are bond pairs. So first we are drawing bond pairs in Lewis structure, then the lone pairs which are present on fluorine like this, on fluorine like this, fluorine like this, and this is bond pair, the lone pair on fluorine like this. So now how many electrons total become? Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So total electrons up till now become 24. And you know chlorine octet has not been completed, so 2 electrons will come here. But still now, after having 2 more electrons, the total electron become 26. That means 2 electron must need to be there as well, so they would come at chlorine. So now you can see that chlorine has an expanded octet. Okay, there are more than 8 electrons which are present around chlorine, so ClF3 will be the right answer for us. Next question says, but if you see like all other elements here, like carbon valence electron are 4 plus 4 times 7 is going to be 32, and carbon, this is Cl, this is Cl, this is Cl, this is Cl. First bond pairs are there, okay, and then we are going to have lone pairs. Okay, then we are going to have lone pairs. If we see now the number of electrons there, they would become 1, 2, 3, 4, 5, 6, 7, 8. 8 times 4 is 32. So it follows the octet rule. Similarly, if you see PCl3, it has 5 electrons and it has 7. So this one would become 26 electrons. And this is phosphorus, this is chlorine, this is chlorine, this is chlorine. And afterwards you are going to draw the lone pairs. So these are lone pairs on chlorine, these are lone pairs on chlorine. And now the electrons becomes 1, 2, 3, 4, 5, 6, 7, 8. 8 times 3 is 24. 2 electrons remains, which will come at the top of phosphorus as the lone pair. So this also follows that rule. So this is not answer, this is not answer. Similarly, if we see NO3 minus, then it is going to have 5 electrons plus 3 times 6 plus 1. So this one would become 24 electrons. And now nitrogen is like this. Oxygen comes here, oxygen comes here, oxygen comes here. So we have electrons here. And then we have so now it is going to have a minus charge there, but if you see the number of electrons has been fulfilled, but nitrogen octet has not been completed. So what will happen, the lone pair on one nitrogen would be removed and double bond will come at this point, nitrogen double bond oxygen. So it is going to be like this, then it is going to be like this. So now it is going to have a negative charge, so it also fulfills the octet. So this is the one which doesn't follow it. For the next question, it is like the same question as which compound does not follow the octet rule. So it is going to be SCl4, and why SCl4? Sulfur belongs from group 6 having 6 electrons, chlorine belongs from group 7 having 7 electrons. So this one would become 6 plus 28, that becomes 34. So sulfur is like this, chlorine is like this, chlorine, 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 having bond pairs first. These are bond pairs, and then we are going to have lone pairs on chlorine. Now each one is having 8 electrons, so total electrons becomes 32. So still 2 electrons comes, which will come as a lone pair on sulfur. So that is why you are going to say it does not follow octet rule. Octet rule. In the next question, they say what is the correct formula to work out the formal charge on the atom. So the formal charge on atom is going to be, the right option is A, because formal charge is going to be the valence electron minus 1 by 2 bonding electrons and minus non-bonding electrons. Okay, valence electron minus 1 by 2 bonding electrons minus 1 non-bonding electrons. So the option is A. So now they are saying what is the formal charge on atom 1 in hydrogen phosphate ion. So first of all, the formula is going to be formal charge, that is equal to valence electron minus 1 by 2 bonding electrons minus non-bonding electrons, and we need to find it on oxygen. So valence electron here is going to be 6 minus 1 by 2 bonding electrons are this 1 and 2, and you can see 1, 2 and 2 electrons are also bonded with hydrogen. So we can say it is going to be 4 minus how many non-bonding electrons are there? They have lone pair here, lone pair here. So which is going to be 4 out there. So this would cancel with this. So 6 minus 2 minus 4, and that one would become 0. So our answer is going to be A option. Then again we have formal charge, that is valence electron minus We have 1 by 2 bonding electrons minus non-bonding electrons. So valence electrons are how much? If we are considering, you can say atom 2, that is phosphorus. Phosphorus belongs from group 5, and it has how many electrons in its outermost shell? That is going to have 5 electrons because it belongs from group 5. 1 by 2, how many bonding electrons are there? So bonding electrons are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So there are 10 minus non-bonding electrons are 0. So 5 minus 5 minus 0, that also becomes 0. So our answer is A.